My name is Tanya, as I mentioned. Thank you so much for the warm welcome. I always like to poll the room before I get into a talk in terms of who's here. I'm told this is a data engineering conference, so I'm curious how many of you would identify as data engineers, data scientists, practitioners. Okay, very good. What about academics? I know there's a few folks here from Berkeley, obviously the previous talk. Okay, a few as well. And how about specifically founders of companies? I'm really curious, or maybe former founders. All right. So for the Bay Area, this is what I would expect. Any product managers? Oh, a few product managers, great. Folks like me. All right, so let me tell you a little bit of my background, and then we'll get into the main topic. As Sai mentioned, I run product at ClickHouse. My background actually is in academia. I was a computer science major. I got a master's from the University of Washington. And that's actually where I got advice to go into industry. I was looking around at what to do with my background. I had a little bit of a consulting background. I was on the academic track, but then decided to kind of go back. And they said, why don't you combine your skill sets and look into product work? And I honestly did not know what it was, and I kind of made it my own. From the very beginning, I loved open source, and so I started specializing in early stage open source companies, and specifically looking at commercial ways of making them successful. Before ClickHouse, I spent 7 years at Elastic, the company behind Elasticsearch. You've probably heard of it. It was an amazing ride, learned a lot, and trying to apply some of the lessons learned here. Today I'm going to talk about the data warehousing space where honestly I'm not an expert. So at Elastic I was responsible for the logging use case. So I spent a lot of time actually with DevOps, SREs, actually any SREs here, DevOps, SRE folks. I do actually think, and we heard the talk from Datadog, that the SRE space from a data perspective will start getting closer to data engineering and data science. It's already obvious that a lot of data science techniques are necessary to make observability use cases successful. So why not? Why should the data stacks be separate? But admittedly, I was not an expert in data engineering, and so when I joined ClickHouse, I learned a lot about the space, and I wrote this blog. If you look at the date, this is now 1.5 years ago. And at the time, I was quite nervous. I was like, am I saying something wrong? It seems to me like the data warehousing space, which was traditionally very verticalized, is basically unraveling or unbundling. And now it's obvious. Look at it, you're like, of course, this has happened, Tanya. This is not new. At the time, it was a little bit risky as I saw it. If you were in the keynote and you heard Julian from Datadog talk, a lot of the things that he described, I completely agree with, right? The data warehousing space, why did it form? Well, databases, which were storage and compute unified, didn't fit bigger data sets that were needed for critical decision making. So data warehousing evolved as a discipline to make that possible. At first, it was very, very proprietary. Hadoop was the first open source innovation there. And that continued to evolve until we had cloud data warehouses. Because of the nature of the data set, it took a while to move those into the cloud. But once Redshift, BigQuery, Snowflake made it possible to move these data sets in the cloud, one thing happened that was pretty interesting. And this is the part I started looking at from my perspective at ClickHouse. A lot of developers, now not only data engineers, data science, but really developers started looking at these data sets and saying, they're much more accessible to me, right? It's much easier to use Snowflake or BigQuery compared to a very kind of traditional data warehouse. Just their model also wasn't perceived. And so you were able to build applications on top of it. So developers started innovating. A lot of innovation happened as a result of data warehousing becoming cloud first or cloud native. And so they started building applications. Some applications they were building are the types of applications that we see a lot at ClickHouse. Immersive, interactive, data-driven applications. We'll see if this video plays. Wi-Fi has been a little bit off. This is actually a public demo that ClickHouse hosts, ClickPy. If you're a Python developer, all of the analytics around Python downloads goes into a giant data set, multiple trillions of rows. We store this in a publicly accessible service, and you can navigate your data. You can filter, you can search, you can look at geo aspects of it. This is an example of an application, right? This is a giant data set, but you have to very quickly get to the data that matters. ClickHouse is a database that basically specializes in that, right? You can try to build this kind of application on top of a traditional data warehouse as well, but you would run into some constraints. The first one is going to be, well, data warehouse wasn't built actually for publicly customer-facing application for SaaS. Concurrency is going to be the first challenge you face. And then the queries, while not super slow from kind of a reporting perspective, from an interactive human perspective, they're not going to be interactive enough. You're also going to run into some cost constraints. Again, these are business decisions. There's no technical reason why these solutions have to be costly. It's really packaging decisions, and I'll talk about that later when I start comparing specifically ClickHouse with Snowflake. Different use cases, different packaging strategies, different outcomes for developers building applications. So when you look at the landscape, right, from a standpoint of what's happening with developers using these solutions, this is happening at the same time as when Julian described. You have all these other alternatives emerging. Data lakes, which are open as opposed to these vertically integrated cloud data warehouses, and then open source alternatives specifically for serving real-time applications. So in the rest of the talk, I'll be looking at kind of these two technologies. Are they on a collision course? Really, that's the question. That's the question for me as a product person, right? Should I really be thinking now as open data lake format as the new way to store my data, for example, right? ClickHouse right now has a proprietary way to store data. Or will they need to be used side by side? This is what I'm going to examine. But first, let me start with a few basics. This one, I'm really thankful again for Julian's talk because he went pretty deep into data lakes and a lot of the concepts I'm going to assume all of you know. If I look at a lot of my customers, and actually I show this slide sometimes in like QBRs with some of my enterprise customers. I say, well, this is a typical data stack. They say, Tanya, actually that's quite simple. My stack is more complicated than this, even though this looks like a mess, right? As I already mentioned, observability and cyber is a completely separate stack. If I'm just looking at data engineering, data science, there's all these vertically integrated data warehouses and all the ETL tools that you really need to use to move the data around. That's the past. With open data lakes, the promise, at least, is that we can all agree on the same storage format for the data and how to search that data with the catalogs, and ultimately just have a bunch of query engines. You see the usual suspects at the top, plus ClickHouse, right? All of us can agree on querying this data in the same way. To me, by the way, as somebody from an academic background, this just makes sense. It is elegant, it is simple, it seems technically feasible. As Julian described, all the pieces are there. And I'll just kind of fast forward, and I'm not going to go into too much one-on-one. You can read about this. There are different concepts around open data lake formats themselves, which are tables, file formats. Typically, at this point, what you see is Parquet with some combination of Iceberg and Delta Lake. That's what you typically see in the industry. Okay, so those are data lakes. Let's take a look at analytical databases like ClickHouse. And by the way, who here has heard of ClickHouse? All right, let the record show about half the room. That's great. Okay, so ClickHouse is on the very far end of the spectrum when it comes to databases that are optimized for highly concurrent, customer-facing, kind of interactive data-driven apps. The name ClickHouse comes from Clickstream Data Warehouse. So originally it was built to power an application like Google Analytics. In fact, a competitor to Google Analytics, Microsoft Clarity, runs on ClickHouse. So if you think about that, that's like every click from a subset of the internet, you put it in a giant database, and now you have to build these charts to navigate the data, right? That's the kind of problem it was built to solve. Obviously, not every data set is that giant, and not every application has the same constraints, but I would say more and more applications are of that sort. And so as a result, popularity of databases like ClickHouse, if you actually put it on the same time scale as even very popular databases like Postgres and Mongo, you see that interest skyrocketing. It's because the nature of the applications we're building is changing. That's the reason. ClickHouse, is quite popular. There are others that you may have heard of. Pinot, Druid, Elastic, even the company I worked at before, Elasticsearch, is actually an application that I would put in the same category. Interactive, data-driven sort of application provider, primarily focused on search and unstructured data, whereas ClickHouse comes at it more from the structured side. And we can talk about the differences. All right, so if you dig a little bit more into what are the types of applications you would consider real-time, data-driven and interactive. I already mentioned customer-facing apps. And if you're in the Bay Area, of course, you've heard of Cloudflare, or actually anywhere, you probably have heard of Cloudflare. They're a huge member of our community. They host our meetups in San Francisco. They use ClickHouse to power their customer-facing charts based on a bunch of telemetry. Trillions of requests go through this system. They also use it for internal purposes. Similarly, Lyft runs basically an internal data warehouse on ClickHouse. At our user conference at the end of May, they'll be talking about this use case in public. Again, a big data set, not quite as big as Cloudflare, obviously, but looking at it more for internal analysts. And this trend is actually kind of interesting because internal users have more and more options. They can buy off-the-shelf tools. So data engineering teams, data science teams are under pressure, frankly, to deliver the same experience on top of their internal data sets and the tools that they provide. I know, for us it's the same situation. We have an internal data warehouse based on ClickHouse, and I, as a product professional, have a choice. I could buy a SaaS service, or I could go to my internal team and use their services. And it's an interesting sort of trade-off. Happy to talk about it with anybody that's interested after the fact. Netflix spoke at our Los Gatos meetup about 3 weeks ago in March, and they talked about an observability use case. Again, why would a company build an observability use case on top of an OLAP database? But it's increasingly commonly done because the problem is not that different. In the end, it's just telemetry, and you want to enable filtering. The data is becoming more and more structured over time because of open telemetry. Cognitive is an ad tech company who's doing model training. Why would you do model training on top of an OLAP database? Because you want it to go even faster. They think that by developing models faster, they can maintain a competitive edge or increase the gap between them and their competitors. So those are some of the use cases. They are increasingly commonly combined with data lakes. So Netflix is an obvious example. As the creator of Iceberg, you might imagine they have huge amount of Iceberg data. Of course, that they basically that's their source of truth for everything. And then you have to, as a provider of data, integrate with that stack. But I think it's going to become more commonplace. All right, a few other things to point out. So I would say for us, as well as other OLAP databases, data science use cases are on the rise. I've already mentioned one of them, which is kind of offline feature store for model training. Model inference is another one. Once you have features to serve to applications, that's a use case that's a great fit for an OLAP database. We end up partnering and kind of going to market with players that specialize in training models, and then we are the serving layer for those models. There's a lot more use cases, observability, data exploration, and so on. The latest one that's interesting is agent-facing analytics. Who here has used an agent to talk to your data warehouse? Claude, yeah, it's life-changing. We actually just released a public demo, so we have a bunch of data sets that we provide for free to the public. And you can go and query it with SQL, or you can query it with Agent House. Very smart name. We're not good at naming, we're good at building databases, okay? So you can go to Agent House and you can ask it, first of all, like what data do you have access to? It tells you. You can ask it, like me, when should you post on Hacker News? In the end, it's just queries. But agents, they actually issue a lot of queries to get to an answer that maybe an analyst would write more efficiently. As a result, actually, that interactive, like how fast each response comes back, becomes very important. So we're seeing a lot more interest from internal teams. They're building for their constituencies with agents saying, you know what? I need a much more interactive paradigm because of the agent-based workflow. We call it agent-facing analytics. You can try this yourself, llm.clickhouse.com. It does ask you to register, but then it's a free access via this Agent House. And according to Agent House, Monday is the best day to post at a specific time. I won't reveal it. You'll have to find the answer yourself. Okay. Let's talk a little bit about speed. So if you have heard about ClickHouse, you probably have heard us make these pretty bold claims about performance. ClickHouse is the fastest, ClickHouse is most efficient. It's true, right? We really focus a lot on efficiency and speed. We actually see them as combined. If you store data efficiently and really thoughtfully, you can query it more efficiently. You end up using less memory, you scan less data, and as a result, you cost less and you return results faster. It's tons and tons of detail. We actually have a VLDB paper from last year that goes into all of the secrets of ClickHouse. None of them are secret. We're an open source database, everything you can find, but it tries to condense, many years of development and optimizations into however much they give you in a paper format. We'll probably write more. So even though, again, it's optimized and quite specialized, it feels like a normal database. If you're coming from Postgres, if you're coming from MySQL, you can just use it. All right, let's talk about real-time analytical databases as a category. I mentioned there are other ones that you can consider in the same category. Why would you consider using a real-time analytical database with a data lake or, versus a more traditional data warehouse, and how would you go about it? Let's first take a look at who I would consider to be a leader in traditional data warehousing, Snowflake. They're one of the sponsors for this conference. They're well known. As I mentioned, I consider them an innovator. They brought a category of products I thought would always stay on-premise into the cloud. I think that's great. If you take the same application I showed you earlier, ClickPy, and try to build on top of Snowflake, this is what's going to happen. And none of this is, again, just me talking. You can go read through these benchmarks. They're all open source. There's a few challenges you're going to run into. Data compression, over which we agonize, right? Like, how do we reach the compression levels that I've shown you? There are specialized data types. There are specialized codecs. There's all these things you can do. In some use cases, it matters less. So this use case, actually, we found that Snowflake there's only like a 20% difference in compression, so not too bad at all, actually. But in some use cases, it really matters. Again, coming from Elastic, I was shocked when I heard about the levels of compression that ClickHouse could reach, because Elastic, that wasn't the focus, right? The focus was simplicity of getting data in, indexing everything. We actually expanded the size of your data set to make that happen, whereas ClickHouse compressed it sometimes 10x or more. For like logging use cases, it was the gap was very, very wide in terms of what Elastic could achieve in terms of compression and ClickHouse. Anyway, in this use case, data compression is not so bad. It's really on the compute costs where the difference happens. We tried many optimizations to get Snowflake to perform at the same level of interactivity as ClickHouse, and we were able to get there in some cases, but at a huge cost. There was still a performance gap, 2 to 3x, depending on the percentiles that you looked at. And at some point, Snowflake just stopped, basically, like you would add more compute and it would no longer return results faster, so you couldn't really horizontally get to where you needed to go. But the biggest issue was cost. And these are product decisions, right? Materialized views in Snowflake are in the enterprise tier. Well, for real-time analytical apps, it's table stakes, right? And you're putting in the most expensive tier. Okay, well, that's going to make lives of developers very hard. Certain other compute costs, basically, for a real-time use case also ended up adding up. So the biggest sort of takeaway from all of these benchmarks, and again, there's a very long blog, is that real-time analytical databases for building apps like ClickPy, the reason they are necessary is because they ultimately are just the right tool for the job, right? A more general purpose data warehouse is not going to appeal to every use case. A real-time analytical database is going to be a pretty significant benefit if you're choosing it for the right job. All right, let's take a look now at why you would combine real-time analytical applications with data lakes. Famously, by the way, Snowflake, it's actually, I find it really ironic. So, from a perspective of who really popularized data lakes, you have Databricks, of course, with Delta Lake. You have Snowflake, who was maybe a late entrant, but it's really the company that popularized Iceberg, which I ultimately see as the more prevalent sort of data lake in my customer environments. In any case, so if you take a look at the questions that I'm really asking myself as a product person for my company, which is, should I basically invest in an additional storage layer in ClickHouse, directly querying on top of a data lake type format? For me, it's clear that we need to do that, and we're doing it at a pretty fast pace. But as a user, right, deciding whether you should use a data lake or a specialized database, there's a few things that you have to ask yourself. One is, how quickly can you write data to a database versus a data lake? And Julian touched on that, right? He talked about how right now data lakes are not necessarily optimized for very fast streaming writes. The second one would be, again, the speed of queries. So let's take a look at each one. From a write perspective, the thing that we found, and again, there are benchmarks in a link below, is that real-time analytical databases are optimized for streaming ingestion at a very high throughput. That's typically achieved by controlling an ingest block size, which makes sense. And you don't have that much control with data lakes around this aspect. This can be changed, right? As with any open standard, you can evolve the standard. The question becomes, will it evolve quickly enough? And so for me, again, as a product person, I'm probably going to hedge. My assumption is going to be that innovation will probably happen still in proprietary formats, and eventually, over time, the most interesting and important ideas will make, and commonly useful ideas, will make it into the standard. So I'm going to assume that Iceberg is going to evolve, Delta Lake is going to evolve, and over time, they'll support more of the streaming rights. At the same time, there's a second aspect, which is if you have a common pipeline for many use cases, you're a data engineer trying to decide basically how quickly to write to your data lake. In the end, there's also a question of how many resources you've allocated for parallelization of those writes. And that's a cost trade-off, basically. The more compute you add, in the end, you kind of have a little, like at first it's obvious, you parallelize, and you have huge returns on investment. At some point, that line becomes more flat, and it becomes less obvious that you should continue to double your compute resource to get just slightly more faster and more optimized and up-to-date writes. So my guess is going to be, it's like trouble of the commons, if you have multiple use cases, just business decisions will dictate how quickly and how up-to-date you're going to keep your data. And for some use cases, you may still need additional streaming insert. So this is on writes. On reads, I think there's kind of an interesting, maybe even innovative dilemma here for a lot of us in real-time analytical database companies. Right now, if you take a native format, say for ClickHouse versus, again, Iceberg and Delta Lake, of course, we're going to be a lot faster in a native format. You see that green column, just millisecond level latency. This is how our database is meant to work. If you just take like a data lake format out of the gate without any additional metadata that we write, any optimizations, it's not going to be great. But with time and with investments, and especially with custom metadata, I do think this delta can shrink and will shrink. And so the question becomes, how close does it get? But then there's also a question of innovation. We're going to continue to push the envelope on optimizations. How quickly will the format continue to evolve as proprietary formats also change? Yesterday, there was a fireside chat with founders of Mother Duck, Startree, and ClickHouse. Yuri, one of our co-founders. All of them were a little bit skeptical, basically, that the gap will close to the point where proprietary formats will become completely obsolete. There'll probably be some hybrid approach, and I agree with that. Just to illustrate the difference between just like the experience, right? I do want to show you an example. So we have a bunch of public examples. I've mentioned already Agent House. I've mentioned the LLM showcase. There's a bunch of also tutorials in the docs. And you can just take, like I'll just show you how simple it is to take a look at something like ClickHouse. You can grab a tutorial. You can install, ClickHouse is open source, right? You can just install it locally. You can use a cloud if you want. There's also embedded versions of ClickHouse if you want to try it as part of your Python notebook. The install is literally that. You just copy, you get one binary, a single binary. Much, much simpler, certainly than setting up a data lake, let's put it that way. But even as far as databases go, it's a pretty simple setup that you can just start in minutes. There's a few modes that you can use ClickHouse with. You can connect to your existing data lake. You can federate queries between local storage and a data lake. We have support for the usual suspects, obviously, from a read perspective. What you'll find, and again, this is like an example just from this tutorial, is that Queries against data lakes, especially on unoptimized formats. This one's not really a fair example. It's CSV. It's not an optimized format at all. Parquet is going to do a lot better, but they're going to be significantly slower. From what we've seen right now, it's going to be sometimes an order of magnitude, sometimes a little bit less. And that's not great. It's not the best experience, not the best. You can't build an interactive application on anything that is, I would say, over a second latency. Like once you get into seconds, the application is not going to feel interactive. So you can load it. You can load the data into ClickHouse. There's tons of ways to load data. I'm not going to go through all of them. We just don't really have the time. And then once you've loaded the data, you can query it. And the query is on top of ClickHouse, and I'm just showing you the Cloud Console here for just as an example. You'll see, you'll actually miss it. See, it's at 10 milliseconds. Like I miss it already. Most of the, like my favorite reaction when somebody says, "Oh, I've tried ClickHouse. I think there was an error. It was too fast. There must have been something that I did wrong." That's my favorite reaction. That's what you need for a real-time analytical application. Like the latency has to be in milliseconds for it to be, to be that interactive on large amounts of data. So it's a big delta, and this is why, at least for now, we're sticking with proprietary formats in addition to working with data lakes. The question I get asked the most from customers in this scenario is, okay, but how do I organize this? And what are you doing as a vendor to support this hybrid usage? So there's a few things. If you need to have data faster, basically, than your data lake can provide, you need to do dual writes. It's not ideal, but you can have very fast ingest into an analytical database, your dual write to your data lake. Data lake is your source of truth. There's a few things that you would then do. Local compute, of course, that's what you would use for very fast queries. You can also, this is what Netflix does, query against data lake for warm data and for your local storage for hot data. You can write data summaries into your data lake as well. And that speeds up some additional queries on top of that data lake. So that's the fast data path scenario. The scenario when you don't need as kind of fresh of a data is simpler. You simply write in the data lake. You asynchronously load that data into your query layer, the speed layer, if you will. And you can still optionally write data summaries and speed up queries after the fact. So this is something that we've seen customers do when, for instance, the use case could be like a speed layer for serving data from models. That's something that we typically see in a data science scenario. All right, a few takeaways before we go into questions. I think at this point it's pretty clear that the traditional data warehouse with a completely vertically integrated storage layer is not something that most vendors are going with. Most vendors that I've seen at this point move to some sort of hybrid approach of local storage and data lakes. From an analytical DB perspective, the pro kind of going with a proprietary format is they can innovate faster, and you can have some specialized logic that simply does not really belong in an open standard that maybe is use case specific. So, we really see this combination of data lakes and analytical databases evolve to be the main way to think about these use cases. When I talk to practitioners, the first question I get is like, well, how do you identify a workload that is a good fit for like this hybrid usage to move into a speed layer on top of a data lake? There's a kind of a very interesting and easy way to do it. You look at your bill and you look at applications that have the highest compute consumption. Usually that's the first thing to kind of go and check out for. Maybe it's a very highly concurrent application that's just scanning a lot of data. And because of the billing models that BigQuery, Snowflake, and others have, often that is a good candidate to take a look and make sure that that's not an application that would benefit from like a real-time analytical speed layer.